What do the following things have in common? This oozing lava, the water in these thundering ocean waves, and the clear air surrounding these mountain peaks. Surprisingly, all these things are examples of solutions. What are solutions? What are some of the different kinds of solutions? And what are their characteristics? During the next few minutes, we're going to answer these questions and others as we explore solutions at work. Every time you take a gulp of soda or powdered fruit drink, you're drinking a solution. And when you take a breath of air or grab onto a doorknob, you're using solutions. So what exactly are solutions? A solution is a type of mixture made of two or more substances that are evenly distributed. This saltwater solution, for example, is made up of water and salt, two different substances. The juice in this container is a solution. You observe. Does the juice in the bottom look different from that at the top? No, the juice solution looks the same throughout. A solution has the same properties throughout. The process by which particles in a substance separate or spread out evenly in a mixture is called dissolving. The solute is the substance that is dissolved. In this case, the powdered fruit drink is the solute. And the solvent, in this case water, is the substance in which the solute is dissolved. Another way to put it is that the powdered fruit drink is soluble, or is able to dissolve in water. Not everything is soluble in water. For instance, oil is insoluble and is unable to dissolve in water. It forms a mixture that is not the same throughout. It's important to point out that not all solutions are liquids. The air we breathe is a solution made up of several different gases, including oxygen and carbon dioxide dissolved in nitrogen. Solids can also be solutions. Volcanic rocks formed from cooled molten rock, for example, are solutions made of several different substances. Alloys are another type of solid solution, consisting of metals or nonmetals dissolved in metals. The steel in this bridge is an alloy. It's made of carbon and other substances dissolved in iron. And brass is an alloy, consisting of the metal zinc dissolved in copper. Have you ever taken a sip of lemonade that tasted exceptionally sweet? This is because it has a high concentration of sugar. These experiences are related to the concentration of solutions. What is concentration? Concentration is a measure of the amount of solute dissolved in a solvent. You compare. What has a greater concentration? The cup of tea with 2 tea bags or the cup with 1 tea bag? That's right. The darker cup of tea brewed with 2 tea bags has a greater concentration of tea. You might refer to this as a strong cup of tea. A great deal of solute, in this case tea, is dissolved in a solvent, which is water. Let's take 2 beakers, each containing 100 milliliters of water. They have the same amount of solvent. We'll add 10 milliliters of solute to the first beaker, and to the second beaker we'll add a lot more solute, 30 milliliters. Which solution has a greater concentration? That's right, the second solution is much more concentrated and even looks darker. How can we make the solution less concentrated or more dilute? That's right, we can add more water to make it less concentrated. Have you ever noticed that some things dissolve better in water than others? You compare. How does salt dissolve in water compared to pepper? As you can see, salt dissolves more readily than pepper. Solubility is a measure of how well a solute can dissolve in a solvent at a given temperature. Temperature plays a key role in solubility. For example, sugar dissolves much more readily in hot tea than in iced tea. Quite often, when making foods such as candy or fudge, it's necessary to heat the mixture so that sugar can be dissolved. Several factors affect how quickly a substance is dissolved in a liquid solvent. Perhaps you've noticed someone stirring sugar into a drink. Stirring and shaking increases the rate of dissolving. Crushing a solute also helps accelerate dissolving. This increases the surface area of the solute being dissolved, providing more contact with the solvent. In some cases, a solvent cannot dissolve any more solute. The water in this solution, for example, cannot hold any more sugar. Notice how the sugar is settling to the bottom. This is referred to as a saturated solution. Solutions play an important role in our daily lives. Many of the things we drink are solutions, and many of the foods we eat are prepared in solutions. Water, often referred to as the universal solvent, is used to dissolve hundreds of different substances. In manufacturing processes, a wide range of solutions are used to produce thousands of different products that we use every day. How do you think this lime tastes? That's right, it tastes very sour. Many acids, such as those in lemons and limes, have a sour taste. What exactly are acids? Acids are a group of compounds that share certain properties when dissolved in water. Do not taste an unfamiliar acid, as it may burn you or make you sick. Acids also react with metals and other substances in specific ways. Acids affect the colors of indicators. Indicators show a definite color change when mixed with an acid or another group of compounds called bases. Notice how this litmus paper, a common indicator, changes from blue to red when placed in this acidic vinegar solution. There are many common acidic solutions in your home, including vinegar, soft drinks, and fruit juices. Acids are used to make many things. Sulfuric acid is widely used to produce paper, paint, detergents, and car batteries. Bases are different substances than acids. When dissolved in water, bases share certain physical and chemical properties. Bases, such as soaps, usually taste bitter. You observe. How does soap feel when touched? It's slippery. Many bases are slippery to the touch. Some bases can be poisonous and corrosive. Never use taste or touch to identify an unknown substance. Bases turn litmus paper from red to blue. Like acids, bases have many uses. Sodium hydroxide, for example, is used to make paper, soap, and is used in products to unclog drains. Ammonia, another base, is a common household cleaner. And magnesium hydroxide and aluminum hydroxide are used in antacids to treat heartburn. During the past few minutes, we've discussed the fascinating features of solutions. We began by exploring some of the basic characteristics of solutions and explaining the differences between a solute and a solvent. We saw that solutions are not only liquids, but gases and solids as well. We explained that concentration is the amount of solute dissolved in a solvent. Solubility, or the measure of how well a solute can dissolve in a solvent, was highlighted. The various factors that affect how quickly a substance is dissolved were described. Finally, the fundamental characteristics of acids and bases were explored. So, the next time you drink a solution, use an alloy, or wash your hands with soap, think about some of the things we've discussed during the past few minutes. You just might think about solutions, acids, and bases a little differently. Fill in the correct word to complete the sentence. Good luck, and let's get started. Number 1. A solution is a type of in which the particles are evenly distributed. Number 2. In a solution, the is the substance being dissolved. Number 3. Is a measure of the amount of solute dissolved in a solvent. Number 4. Is often referred to as the universal solvent. And number 5. Such as vinegar, usually tastes sour.